Geology is the study of the Earth, its materials and the processes acting upon them. It helps us understand the planet's history and predict future geological events. Imagine standing on a beach, feeling the sand grains between your toes. Each grain tells a story that spans millions of years. This is the essence of geology, examining the Earth's layers to uncover its secrets. Geologists decipher this story, revealing the history of our planet. They study volcanoes, earthquakes and fossils to understand past environments and life forms. This knowledge is vital for predicting natural disasters and finding resources like water, oil and minerals. Geology is not just about rocks. It's about understanding the dynamic world we live in, from the majestic peaks of the Himalayas to the vast plains of the Sahara. Geology is the key to unlocking the mysteries of our planet. Physical geology focuses on understanding the materials that make up the Earth and the processes that shape its surface. It deals with the study of minerals, rocks, soils, and the movements within the Earth's crust. This branch of geology is fundamental for identifying natural resources and understanding geological hazards. One of the main areas of physical geology is mineralogy. Mineralogists study the chemical composition and physical properties of minerals. By analyzing minerals, geologists can determine the conditions under which rocks were formed. Another key area in physical geology is petrology, the study of rocks. Petrologists classify rocks into three primary types: igneous, sedimentary and metamorphic. Geomorphology examines the Earth's surface features and the processes that create them. Physical geology provides the tools and knowledge to explore the Earth's past, present and future. Historical geology is the branch of geology that deals with the history of the Earth. It focuses on understanding the origin and evolution of our planet through time. By studying rocks, fossils and geological formations, geologists unravel the history of life and environmental changes over millions of years. One of the primary tools in historical geology is stratigraphy. Stratigraphers study rock layers, strata, to understand the sequence of geological events. Paleontology, another key area within historical geology, focuses on studying fossils. By analyzing fossils, paleontologists can infer the characteristics of past environments and the organisms that lived in them. Geochronology is the science of determining the age of rocks and geological events. Techniques such as radiometric dating allow geologists to assign precise ages to rock formations. Historical geology provides a comprehensive view of the Earth's past, helping us understand how current landscapes and life forms have evolved. Catastrophism is a geological theory that suggests Earth's landscape has been shaped by sudden, short-lived and violent events. This idea was prominent in the early days of geology when scientists observed dramatic changes in the Earth's surface. They believed these changes were the result of catastrophic events such as volcanic eruptions, earthquakes and floods. One of the earliest proponents of catastrophism was Georges Cuvier, a French naturalist. Cuvier believed that the Earth's history was marked by a series of catastrophes that caused mass extinctions and rapid changes in the environment. He argued that these events were responsible for shaping the Earth's surface and creating the fossil record. Catastrophism was a dominant theory in the 18th and early 19th centuries. Supporters of this theory pointed to evidence such as large-scale volcanic deposits and the sudden appearance of new rock formations. However, catastrophism faced criticism as more evidence emerged supporting gradual geological processes. Section 5. The principles of uniformitarianism. Uniformitarianism is the principle that the same geological processes we observe today have operated throughout Earth's history. This theory, first proposed by James Hutton in the late 18th century, suggests that the forces shaping the Earth now, such as erosion, sedimentation and volcanic activity, have always been at work. Hutton's ideas were revolutionary at the time and contrasted sharply with the catastrophism theory. He proposed that the Earth was much older than previously thought and that its features were the result of slow, continuous processes. This concept was later popularized by Charles Lyell in his seminal work Principles of Geology. Uniformitarianism is often summarized by the phrase, "The present is the key to the past." This principle has been fundamental in shaping modern geology. It allows scientists to interpret the rock record and reconstruct the Earth's history accurately. Section 6. The rock cycle, nature's process. The rock cycle is a continuous process by which rocks are formed, broken down, and reformed over time. This cycle describes the transformations between three main types of rocks: igneous, sedimentary, and metamorphic. Understanding the rock cycle helps us appreciate the dynamic nature of our planet. Igneous rocks form from the cooling and solidification of molten magma or lava. Sedimentary rocks are created from the accumulation and compaction of sediments. These sediments can be fragments of other rocks, mineral grains, or organic material. Metamorphic rocks arise from the transformation of existing rocks under high pressure and temperature. The rock cycle is a testimony to the Earth's dynamic nature. It shows how rocks can change from one type to another over geological time, driven by processes such as volcanic activity, erosion, and tectonic movements. Section 7. Formation of the Earth. The formation of the Earth is a fascinating story that began about 4.6 billion years ago. Our planet formed from the dust and gas surrounding the young sun. These materials clumped together through a process called accretion to form planetesimals, which eventually merged to create the Earth. In its early years, the Earth was a molten mass, bombarded by meteorites and volcanic activity. Over time, the planet cooled and a solid crust formed. Volcanic eruptions released gases that contributed to the formation of our atmosphere. Meanwhile, water vapor condensed to form the oceans. The differentiation of the Earth into layers, core, mantle, and crust occurred as denser materials sank to the center and lighter materials rose to the surface. Understanding the formation of the Earth provides insights into the processes that have shaped its history and continue to influence its future. Section 8. Geology's influence on human life. Geology has a profound impact on human life, influencing everything from the location of cities to the availability of natural resources. The study of geology helps us understand natural hazards, find essential resources, and plan sustainable development. One of the most significant contributions of geology is in the field of natural hazard assessment. By studying faults, volcanoes, and other geological features, scientists can predict and mitigate the effects of earthquakes, volcanic eruptions, and landslides. This knowledge is vital for protecting lives and property. Geology also plays a crucial role in resource exploration. Minerals, oil, natural gas, and groundwater are all found using geological methods. Urban planning and construction also benefit from geological studies. Engineers rely on geological surveys to determine the suitability of building sites and to design structures that can withstand geological forces. Section 9. Practical applications of geology. The practical applications of geology are vast, impacting various industries and everyday life. From construction to environmental protection, geological knowledge is indispensable. In the construction industry, geological studies are essential for site selection and foundation design. Engineers use geotechnical surveys to understand soil properties and assess potential risks. This ensures that buildings, bridges, and roads are safe and sustainable. The energy sector relies heavily on geology for the exploration and extraction of fossil fuels and renewable energy resources. Geologists help locate oil and gas reserves, assess geothermal energy potential, and explore new sources of mineral resources. Geology also plays a significant role in agriculture. Soil scientists study soil composition and health to improve crop production and manage agricultural lands. Section 10. Conclusion: the lasting impact of geology. Geology is a science that touches every aspect of our lives. It helps us understand the Earth's history, predict future events, and utilize natural resources responsibly. The study of geology has provided insights into the formation of our planet, the evolution of life, and the processes that continue to shape the world around us. Geology's practical applications are vast and varied, influencing industries such as construction, energy, agriculture, and environmental protection. The knowledge gained from geological studies is essential for sustainable development and environmental conservation. In conclusion, geology is not just the study of rocks, but a window into the history and future of our planet.